This video is on the objective. Calculate and interpret the confidence interval for a population mean with a known standard deviation. And this is number 1, so this is the first video I'm doing on a question related to this objective in your Newton-Alta homework. Alright, so again, if you're unfamiliar with the topic, hopefully you've read through section 8.1 of your OpenStax statistics book. Looked at all those examples, taken notes there. If you're unfamiliar with it still, you can click on more instruction here and read the notes or watch the videos or read the examples that they have for you and see if that helps out. Alright, so here, the lengths in inches of adult corn snakes are normally distributed with a population standard deviation of 8 inches. Right, so they give us sigma, the population standard deviation. See, that's with a known standard deviation up there in the title of the objective, and an unknown population mean. Remember, when you make a confidence interval for a mean, that means you're guessing what the mean is. Right, a confidence interval is a guess. Right, you guess with a certain level of confidence that the population mean or the population proportion or whatever is in this particular range of values, right, this interval. All right, a random sample of 25 snakes, these corn snakes, is taken and results in a sample mean of 58 inches. So we're asked to identify the parameters needed to calculate a confidence interval at the 99% confidence level. Then find the confidence interval. All right, and they give us a little chart here. We're going to use these. It says also you may use a calculator or the common z values above. All right. Well, actually, there's a whole nother objective where the calculator is involved, so I'll wait till those questions to show you the calculator use for this. Alright, so I'm going to go to my page, go to a piece of paper, and kind of draw a picture, a little descriptor of what's happening here. Alright, so we have this population of, corn snakes. Population of adult corn snakes. And let's suppose that a variable called x represents their lengths in inches, right? The length in inches of these corn snakes. And they're telling us that the length of these corn snakes is normally distributed with some mean mu, right, the population mean, and some standard deviation sigma, where mu is unknown. Right, again, we're making a confidence interval for mu, right? So we're going to guess a range of values that mu could possibly be. And standard deviation we're given is known as 8 inches. Right. Now, what we need to do to guess what mu is take a sample. Right, so from this population of adult corn snakes, a sample is taken. A random sample of, n equals 25 snakes is taken. And their average length is calculated. The average length, so again, this x bar is equal to 58 inches, right? The sample mean is x bar is 58 inches. So again, x bar, the variable x bar, if I did this for other samples, imagine you took all possible samples of size 25, all possible samples of 25 snakes, and looked at all the different x bars that came from that. By the central limit theorem, if x bar here is the, again, the average length of 25 snakes, by the central limit theorem, the distribution of all these average lengths of different groups of 25 snakes would be normal, right? Since the population we pulled from was normal, would be normal with a mean of mu x bar, mu sub x bar, and a standard deviation of sigma x bar, where the mean of the means, right, the mean of these x bars was the mean of the population. But this is unknown. We don't know the mean of the population. So what we're going to do is use 58. Right, this was our point estimate, the x bar. Right, you use x bar as what they called a point estimate, right? Our initial guess as to what mu is. Right, sorry about the tininess of that. This is his point estimate. And standard deviation of all these x bars, these average lengths for groups of 25 snakes, is the standard deviation of the population divided by the square root of the sample sizes. Right? Oops, just put n here. And we know the standard deviation of the population, that was 8 inches, right? That was given. Divided by the square root of the sample size. Now this is, this x bar, these are average lengths for groups of 25 snakes. So this is just 8 divided by 5, that's 1.6. That's nothing I need the calculator for. Right. And then I can draw a little picture of this if I want. Of the distribution of these, average lengths of groups of 25 snakes. So here's a number line with, different possible values of x bar, different possible values of the average lengths of groups of 25. So it would be normally distributed, right? So I'm going to do this like symmetrical bell shape. Underneath the peak of this goes our mean. Right, so on the number line here. Now the mean, again, we don't know the population mean. We don't know what mu is. We're trying to guess that. So we use our initial guess, right? 58. Right, that was the sample mean. We use our sample mean underneath the peak here, 58 inches. And the standard deviation of these x bars was, 1.6, right? 8 divided by the square root of 25. And, so underneath these inflection points here, these values should be 1 standard deviation above and 1 standard deviation below. So this value here is about, 59.6. And then this value here is 56.4. Right, adding 1.6, subtracting 1. Those are 1 standard deviation above and below the mean. And if you recall from like the empirical rule, right, remember approximately 68% of the area is under here. So if my confidence level was only 68%, I would say I'm 68% confident that the value of mu, that the actual mean length of all adult corn snakes, is between 56.4 and 59.6 inches. But that's only 68% confidence. All right, what we are asked to find, what we are asked to determine, is we're finding a 99% confidence interval, right? We're doing a 99% confidence interval. So my confidence level is 99%. We have 99% confidence. That means, so instead of going to, just 1 standard deviation above and below the mean, I have to go more than 3. I'm sorry, less than 3. Because remember, 3 standard deviations above and below was 99.7%, right? 2 standard deviations above and below was 95%. So between 2 and 3, standard deviations. Right. So what I'm doing is I'm trying to find a value over here. Remember, this would be 58 plus, some margin of error, or the margin of error. That'd be the upper value of my confidence interval. And then take the same distance, that same margin of error below the middle. There's 58, minus the margin of error. And I'm trying to find what are these two values such that the area between them is 99%. Now, another value that'll pop up, another symbol you're going to see is the Greek letter alpha. Looks like this, kind of like a little ribbon, sideways ribbon. This Greek letter alpha is what's called the significance level. Now, we're not going to worry so much about the words significance level right now. That'll come much more into play when we get into the next chapter on hypothesis testing. But basically, this is the area left over, right? Because if this is 99% in between, then the area left over is 1%, or 0.01. So the value of alpha here is 0.01. And what we're looking for, right? What I'm going to try to do is calculate this margin of error. Now, to find the margin of error, I need to know, remember I said this is going to be somewhere between 2 and 3 standard deviations. I want to know how many standard deviations away from the middle are these upper and lower. So this is the upper limit right here, the 58 plus margin of error. This is the lower limit over here, the lower bound, 58 minus the margin of error. What I want to find out is how many standard deviations away from the mean are the ends of my confidence interval. So how many standard deviations away from the mean or away from the middle are the ends of my confidence interval? Well, how many standard deviations, that's a z-score. Remember z-scores? So what I'm trying to do is find a z-score with a certain amount of area above it or below it. Now, if there's 99% between these two, remember that means there's 1% left. That's the alpha. Now, if there's 1% left, that means this area here above my upper limit and this area here below my lower limit are half of 1%. These are half of alpha, or half a percent, 0.5% or 0.005. Same thing here, half of alpha, 0.5%. That's the area above. And so when we're looking for z-scores, that would be the z-score, right? The z-score with half of alpha above it, and you'll see it written like this. When you see a z-score with a subscript, that means I want to find the z-score with this area above. All right, this is the z-score with area alpha over 2 above it, or to the right of it, right? So that means here I'm finding, all right, so for this particular problem, I'm finding what's the z-score with, half a percent, 0.005 above it. So that's what we're trying to find here. And then once I know this, then I can state this margin of error, right? Then the margin of error is this many standard deviations, is this z-score with 0.5% above it standard deviations. Remember, the standard deviation was this, for the x bars here, was this sigma over the square root of n. So here's like a formula for the margin of error. And I'll write this up on the next page actually too. And you may have seen it in another video before as well. So if we have 1 minus alpha, so for 1 minus alpha percent confidence, the margin of error will be the z-score with half of alpha above it multiplied by the standard deviation, that's sigma over the square root of n, the standard deviation for the x bars, for the sample means. All right, and I have all these values. All right. So for this particular example, the margin of error is, again, z.005. That's from the little chart. See, z.005 here. So it's 2.576 standard deviations above the mean. And that means that the lower bound is 2.576 standard deviations below the mean. But if I go, from the middle, 2.576 standard deviations above and 2.576 standard deviations below, then I'll have two values that have 99% of the area below it, between them, right, under the curve. All right, so that's 2.576. So this z-score with, again, 5% above it, 2.576 standard deviations. And what is the standard deviation? Well, we said that was 1.6 earlier, right? That was this here, right? 8 divided by the square root of 25, 1.6. All right, let me enter what this is. So I'll pull the calculator up. All right, so come on, turn on. All right, so 2.576 times 1.6. So this margin of error is 4.1216. So back in my drawing here with this normal curve for the x bars, the normal distribution, if I'm creating a 99% confidence interval, I'm starting at 58 in the middle here, the sample mean, the point estimate, adding this margin of error, right, this 2.576 standard deviations. So 58 plus 4.1216, that would be a 62.1216 for this upper value. And then 58, minus 4 would be 54. And then we have, so this lower value would be 53.8784. So there's our confidence interval, our 99% confidence interval. And I'll write those values down here. 99% now I'm going to put CI for confidence interval. 53.8784 to 62.1216. Remember, these were inches, right? These were in inches. All right, so based on that sample, what we're given here, what we're saying is we are 99% confident that the value of mu, right, the original population mean, the mean length of all adult corn snakes, is somewhere between 53.8 inches and 62.1 inches. That is what we are saying with all this. Now they did say round the final answer to 2 decimal places, so that would be 53.88 and 62.12. Right, so back on the website here. All right, now let's go through and fill in all these values too, right? What was x bar? X bar is just that sample mean of 58, right? They told us that. Sigma was the population standard deviation. Right, notice that is not sigma x bar, that's just sigma. That was 8 inches, right? That was also given. N was the sample size, right? 25. And then this z alpha over 2? What's the z-score with an area of half of alpha above it. And alpha here, right, 99% was the confidence level. So alpha is 1%, meaning alpha over 2 is half a percent or 0.005. And we saw that here. That was that, 2.576 standard deviations, right? 2.576. And then finally, what is the confidence interval, right? What's the lower bound and upper bound of our 99% confidence interval into 2 decimal places? So that was 53.88 for the lower bound. And then the upper bound was 58, plus that margin of error, 62.12, right? That 58 plus 2.576 standard deviations, right? 2.576 times 1.6. And let's submit. Fantastic. And again, please read through the answer explanations, even if you're correct, right? Just to make sure you're doing what should be done, and the code will be. See, point estimate minus margin of error, point estimate plus margin of error. They got the margin of error formula again when you're doing an estimate for a mean, and all that stuff, right? Yeah, and especially if you're incorrect, right? Definitely read through the answer explanations. Try to figure out where you went wrong. All right, so hopefully this video helps you when you work on problems similar to this in this objective. And thank you very much for watching.